right, we have positive and negative of the battery tender quick connect cable. It's hardwired to the battery. These are from that test light, that junky test light. Okay, the copper has got good copper. That's our plus and our minus. Okay, that is how the relay kicks on. If I go ahead, I horse around with this. Okay, yeah, activates that relay. So, clicks it on. This here is just a switch. If I check my leads, 0 ohms. Okay. Very close to 0. I go ahead and check this. It's got all kinds of ohms. Let me go ahead and put this on here. There. I had 30 or 40 ohms earlier, and then went down to 8. Right now we're up in the K ohms. We're at 310,000 ohms. This is really unbelievable. Let's go ahead, unclick it, and of course, and then re-click it. Ooh, nasty little thing. Oh, oh, oh. The hell's going? Meg ohms now. Meg ohms. The hell? This meter passes a low current through here. It measures what goes out versus what comes back. So, usually it could lead you astray. It'll tell you got 0 ohms when in fact something will collapse under load. But in this case, the meter is doing fine. I really, based on everything so far, and this, I think this relay is a piece of crap. They're sitting at 316,000 ohms. Oh my goodness, how does this thing even work at all? Let's go ahead and hook it back up. Oh, where are we at? I'm still up. Oh, dude. Oh yeah, got one brand new. Only difference is the location of the trigger. It's on this side instead of this side. Everything else about it looks identical. I was on the forums looking at other people with their rigs, and some people were saying that it has to be rated for continuous duty. And the thing is, I couldn't find any kind of description for any of these parts that says that. Anytime when you look at one of these things, it just has a certain shape to it, and it's just called a starter relay. And I called the place, Advanced Auto Parts, and I told them what I have, and they couldn't find it in their system. So I was looking on eBay, and I found one used, and then I did find the part number from Ford. It was just very hard to get. It was like $80, and so I said, all right, well, I found one that looks just like it that has no part number, and it just said starter relay, and so that was $13 on eBay. Wow, I could have bought that. I said, well, let me just go over to Advanced Auto Parts on the bike and we'll see what they have. And I saw the guy there, John, who I see all the time, and well, not all the time, because that would be 24 hours a day, 7 days a week, but as often as I go, I see the guy, and he's awesome, very smart, and I showed him what I have, and I said, yeah, when you bring it in, that's the difference, and you're holding it in your hand, and you could show, this is what I need. I tested it. It feels good to know that the other one was shot, and I found the problem. And I said, you know, these are, it's a 3-pin with the ground on the bracket itself. And he's like, oh yeah. And I said, some F350s and stuff use that as a starter relay. And he said, oh, let me go see what I have for you. And he came back, boom, $36. I said, let me just think a little bit. And I went back out for about 10 or 15 minutes and thought about it. And then I went back in the store and I said, yeah, I'll take it. That's awesome. And it's a bird in the hand. I am willing to bet this is going to work like a champ for years. The other one lasted 20 years. You think how many times it went on and off. Oh boy, this will too. So, we'll go ahead and test it. Okay, we got it on resistance there. And I go ahead and hook this up here. And, here's, oh, we don't want any shorts. Oh, hold on there. Oh, okay, stay. We got perfect, absolutely perfect. Great continuity. And when I unhook it, oh, if you're jittery, it'll go on and off a bunch of times. I don't know if that's good. I want it to be either on or off. I don't want it to go da-da-da-da-da-da. But that's just, that's my hand. Yeah. That's what we want. That's a good relay. I went ahead and I set that to amps, and I moved the lead over to the appropriate spot. I want to see what kind of current it takes to power the coil of this relay. Went ahead and put the leads in series, and you know, it starts at 3, and then as it heats up, I suppose, drops down. And it stabilizes around 2.5 amps. Quite a bit of current it takes to operate this coil. You know, I tried using a 9-volt battery because that's a great way to test one of the, well, a smaller one. A 9-volt battery will test a smaller one, no problem, but it wasn't enough to give this a kick. You gotta have 12 volts, and then you gotta have the juice in order to give it the Bruce. Yeah, see, stabilizing 2.4. Oh, who knows, maybe it'll drop down to 2 after you're driving around for a while. Seems fine to me. And just like the other one, it gets warm. Definitely heats up. And I guess it has to dissipate that wattage. What does the other one draw for current? I don't know. Am I that much of a nerd that I would like to know? Yes, but am I going to? No, because this is just going on and on. I could have actually taken this apart. this is identical to the other one, okay? You grind these rivets off, and a lot of them are like pressed in, but this, it looks like you could definitely just pull the lid off. And there's a guy on YouTube who serviced one of these. It's pretty amazing. I made that decision to just get a new one. Boom, done. I've already spent like 30 hours troubleshooting everything. I mean, that's enough of an investment. I don't have to be that cheap to where I would just have some little bits, and then another 10 hours into this, rebuilding one. I got it nice and new. I got to know, this is the old one. 0.74 amps. Wow. The other one used 2.5. And this one is only less than an amp. Whew. My. Back to the old. Wow. Well, there's definitely a difference with how much juice it's using to activate that coil. If the coil stays activated for a long period of time, it's going to get warm to the touch. Yeah, it's getting warm. And the current does start to reduce. What any coil or resistor is gonna, or light bulb is gonna do when the filament heats up, the resistance is going to increase, and therefore the current is going to go down. Or does it decrease? Well, current's going down. I forget all this stuff, man. Definitely been trained and learned all this stuff. I can't remember. Oh, it just clicked on. That was just the lead here coming loose. That's back on. This has 10 amps for 15 seconds max. Oh, I'm not running 10 amps. So probably because the leads can't handle that and they'll melt. 2 amps it can handle, I'm sure. Just keep an eye. Is that lead getting hot? No. The coil's getting hot. No, it's not getting hot. It's just warm. A little warm. I don't have to run the meter this long if I want to see how hot it gets. We're at 2.3 amps. I just take the meter out of the equation and leave it hooked up and see. You know? 2 amps for 1 hour would be 2 amp hours. So half hour would be 1 amp hour. A 10 amp hour battery, knock it down to 9 amps, 10% discharge. Be okay. A-okay. So I'll leave it for half an hour. See how hot it gets? If it gets too hot, can't use it. Right? I mean, it's gonna have to be on all the time while we're driving. The key is in run. Go down to 2.18 amps. It's definitely starting to get hot. Oh, I can feel it heating up quite a bit. here in a little bit. It'll work its way down to 2 amps. The other one was instantly at 0.7 amps. And then dropping. Definitely has to dissipate that heat. 12 volts times 2 amps is 24 watts. That's heat that has to get dissipated. That's like having 2 of these little fixtures in there on at all times. What kind of fixture? This kind of fixture. This draws 1 amp. So I use this for troubleshooting sometimes. Yeah, these 2 little bulbs. This draws 1 amp. So we got 2 of these in there. The other one has less than 1 of these. Probably just 1 bulb, right? Close to 0.7. It's pretty close to 0.5. That's right in between. It's like 3/4 of one of these. Oh yeah, now 2 amps. How are we doing on heat? Oh, this is getting hot. Wow. Oh, this is heating up a lot, dude. Wow, why is that getting so freaking hot? I'm glad I didn't put that out in the vehicle. Oh my God. Oh, that's gonna melt. Dude, that's heating up. Down to 2 amps. It just can't stay on. It has to come on for a moment and then go back off to start a vehicle. There's something different about the other one. Oh, it's getting really hot. Oh, that's hotter than a jacuzzi. That's like 120, 130 degrees. Oh, let's find out. Thermometer. Yeah, just what I said, 131 degrees. Hello. $136. Oh boy, that's getting hot. Oh. Oh, so my nerdiness, it just doesn't like to be left on for too long. It lets you know. If you put it on ohms, it'll do the same thing. That wire's not getting hot. It's got a fuse in it. It's got a 10 amp fuse. Take the lid off the back. One of those little cylinder shaped fuses. Oh my goodness. $143 degrees. Oh boy. Can you imagine driving around with this and then it melts into a blob? That would be terrible. Let's feel it. Oh, it's getting hot. Oh, the meter shut off. Okay. Okay. This thing is getting hot and it's not any longer making continuity. Take this off here. You hear it a little bit, but it's not working anymore. It's getting extremely hot. Oh my God. What is this temperature in here? 156 degrees. Internally, what do you think it is? And I can smell it. It's starting to make a smell. It's up to 164 degrees. Holy smokes. Depending where you point it. Oh my goodness. And the coil isn't cooperating anymore. When it was cold, it was nice and positive. Right now, I'm not getting continuity. Ouch! Oh, this is getting so... Ooh, it's hot. Friggin' hot. Oh boy. I think we might have to rebuild the other one. So we're gonna leave this other one on there for 5 or 10 minutes. Go have a cigar, and we will see what our temperature is. Okay, so the couple of people on the forums and Jake are correct. This has been going for 7 minutes now, and it's lukewarm. I could feel it kind of warm, but it's not hot. $93 degrees. Yeah, I mean that's seems hunky-dory. So we have a good functioning coil in here. We have the contacting is not taking place, and I know exactly what that looks like inside. I think the other guy that had to cut his open had to fight quite a bit. He didn't have a lid and rivets like I do. I think we're gonna have to try and take this apart and rebuild it. Or maybe we could call Ford and see. I haven't done that yet. It's definitely hard to track down. Sometimes they might be able, you know, it's going to cost probably about 80 bucks. It seems worth it to me. If it's going in the trash anyway, may as well just cut it open. I did call the dealer. It's unavailable. I have to cut this puppy open. Very nice. No screws? Why rivets? You could choose to use screws. Why do they use rivets? Ouch go! Okay, there's a little bit of glue. Oh, let's see, come on. Oh, we need some heat. Well, it was not easy to get it off, but I was very gentle. I worked it a little bit with the screwdriver, got it off. What is that little wire? Is that the ground? I mean, the bracket is the ground. That's very corroded. Wow. How's moisture get inside there? Wow. Okay, I'll figure out how to get this all apart. Very gently went around with the screwdriver and got the gasket lifted up. There's a cork, and this goes only, see how it drops in there? And there's a little ground wire there. I'm going to make the executive decision to cut that, and I will repair it. It's crappy anyway. Just take another strand of wire from somewhere and I'll make it in there nicey nice. I'll clean all this corrosion. We'll get it to where it's okay. And we got contact. This is a cork. There's a little cork in here. See, pull this up. Pull it out. Yeah, we're starting to get into it. We're just gonna cut that. All right. Now we're getting somewhere. We got the lid off, we got the cork off, and the gasket, we got the ground off, and now we're tearing into it. Okay, so what's stopping us from pulling this out is that itty bitty ground wire wrapped and soldered around another wire, and we got another wire wrapped and soldered. Let's see, I don't know if I'm able to unravel that. I don't have a soldering iron. Could heat up a nail and then touch it to it. I think I might just cut that. So then we just use more wire and fix it afterwards. I might just have to cut that. Yeah, buddy. There's my nail. There's a solder remover. It's getting maybe 600, 700, 800 degrees. It gets red. It gets yellow. That's already up to about 1,000, 800. Roughly is unraveling that mess. Getting it off. Okay. So, managed to get that all desoldered. Man, I need a soldering iron. By the time you heat the nail up and you move it over the position, it's no longer hot enough. You dial up a soldering iron, an electric one, you could choose a temperature. It's going to get up to about 700 degrees, 750 degrees. And it needs to stay there steadily. You might need to increase it or decrease it a little bit. But any of those little blow torches or heating up a nail cherry red and then trying to do it, it sucks. You need a freaking soldering iron. So, it's crucial that those wires go there and these wires go here. And that's ready to come out. And there's our coil. Got this little metal, whatever it is here. Ooh boy, getting into it now. There's another piece down here, and got this shell here. Oh, is that part of it? Does it pull on that? Let's find out. Okay, so we pry on this a little bit, and that ring that goes around is going to come out. The ring is out. Got one little itty wire going down in there. Some kind of thing here. We lift that up. Oh. And, oh, what do you know? There's our contacts. Looking like they've seen better days. You see that right there? Uh-huh. The one looks better than the other, but that's, oh yeah. That's the straw that broke the camel's back right there. That's a little dim. And then in here, you see those are our posts. Oh wow. Look at this post here. This one has a shiny copper. And that one that was shabby, it's black and there's just nothing left. Oh my God. This is the hot lead for the little pin for the coil. That's hot and run. And these are our two switch contacts that go down to the posts. You hardly see that one. Oh, I'm gonna clean that up and we're gonna put it back together and it's gonna work. See, what the other guy did with his was he had, this is much thicker copper material, and he was able to just flip it around. It had a good side and a bad side. It was like, there we go, brand new. Me, trying to file this down, it's pitted. It's actually getting, exploded, going pop, 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 with each and every contact that it makes, and then all that amperage, you know, just like when I hook something up and then I get a little spark, that's considered an arc. It's like a welder. After however many thousand times, it looks like it blasted pitting into it. There we have it. That's what the contacts are supposed to look like. And we got that cleaned up as much as possible. Well, it's going to be ready to go back in and go all back together. I'll probably clean out all the dust and all the crud that's in the base there. And that is all back together. It is ready. The lid has been cleaned inside. It's ready to go back on. Let's see which way it goes. It doesn't matter a whole lot. I want it to go back the way it was. Let's take a look at the picture and see how it goes. Okay, it's ready to go back together. Here's what I got. Wood screws, machine screws, miscellaneous 2 wood screws. Itty bitties. Some of them have nuts. That'd be nice. Maybe some of them, the threads will grab in the plastic on the other side. That's the plan. And then hopefully they're not too bulky, interfere with grounding. Although these are stepped. See, they're raised, the ears. So we got a little bit of room for bolt heads. And, well, if they protrude a little bit, so what? It's as if every screw I put through here, it passes through the plastic underneath as well. And then if I get a bigger one, instead of biting the plastic, it bites in the metal. These need to be bigger than the holes of the plastic, just by a little bit. So I gotta drill them out. These here are the best ones that I found. And as you screw them in, they get kind of tight. So you back them out, screw them in, kind of like try to cut threads into the plastic a little bit. Everything went great except for this one. I started tightening it, torquing it down, it cracked. So I'll put some JB weld on it. And I might cut these off. That way they're not all pokey. And it'll look nice. I went ahead and got it all back together, and it didn't work. It had constant continuity. This piece, the contactor, was forced all the way in there at all times because I had the spring in the wrong spot. And now I put the spring in the right spot, and I got everything perfect, exactly how it's supposed to go. And these little wires here, you got to make sure the ground wire comes through and contacts the base plate, and the hot wire is not touching. There's paper around this coil. I went ahead and it was coming off anyway. I'll do something. I'll put some more paper, some shit paper on there, you know, but it has this doohickey here, whatever it is, and it's wired in parallel. This is really just a coil of wire. It's a spool wound up. The outside part goes here, and that is, it mates up with this trigger wire, okay? And then the ground, it's, so yeah, I mean, if you energize it now, nothing happens at all. It doesn't work. I've tried energizing this with just the plunger here to see if it moves, because it somehow moves that plunger when it works. Doesn't freaking work. Okay, there's the contactors and the spring that go in there, and then this collar goes around the outside. And then last but not least, this goes in there, and then the coil goes in. It doesn't work. It's not even passing any current. If I do a test here, try and run current through it, and then see if it becomes an electromagnet. Does something nearby become attracted to it or repelled? No. It doesn't work. It did. The contacts were the only problem. The coil was not the problem. I don't know. I'm just, I can't get the part from Ford. Don't even know what the part number is. Here is the part number. They don't know. The people at the parts store don't know. I have to go back over there and see if they have something, anything. It doesn't have to be Ford. It just has to make stinking contact. It connects the primary and secondary battery together. That's it. I don't know why this thing doesn't work. I should be able to get it back together and have it work. It doesn't. Holy shit. I've spent 7 hours today on this. The whole project so far, probably about 50 hours. That's unbelievable. Definitely gotta have a lot of patience. You gotta tolerate the pain, the amount of mental pain. And that's a coil assembled. Something should happen where this goes and makes the contacts in the bottom of the unit. A magnetic field occurs and that gets yanked down somehow. So, ground, 12 volts. Should work. Ground, hot. Nothing. Absolutely nothing. Why? What did I do? I didn't do nothing. Just took it apart and put it back together. And I took a video of how it came apart so I could put it back together exactly how it goes. It doesn't work now. Never shorted anything out. Whatever that resistor or diode or whatever that stupid little thing is. Maybe it's a capacitor. I don't freaking know. Didn't do anything to it. Made sure wires are intact. Between here and here, I get 15 ohms. And you know, if you divide that from 12 volts, you get 0.7 amps. That's really consistent with what I got. Earlier,